Hello and welcome to the exciting unit of statics in Project Lead the Way's Principles of Engineering course. To begin our statics discussion, we are going to start with section 2.1.1, which covers centroids. In this video, we are going to talk about what exactly a centroid is, what it is used for, and how to calculate the centroid of both some basic shapes and a few more complex shapes. So let's dive right in. An object's center of gravity or center of mass is also known as its centroid. It's labeled with the following icon. That icon looks kind of like a nuclear waste symbol. But basically what happens here is that this center of gravity, this center of mass is where all of our forces interact within when there are forces applied to an object. It's also an area where your object would be balanced. So when we see this picture here, this is very strong man is balancing 25 pounds with one finger because he has put his finger at the centroid. If we put our finger not at the centroid, luckily for him, somehow the weight just rocks back and forth instead of falling onto the floor, but it is off balance and it will not balance there. At this balancing point, it is considered in a state of equilibrium, which means everything is balanced, all forces acting upon it are canceling each other out. So why do we need this centroid location in statics? It is because the theoretical calculations that we are going to be talking about as this unit goes on, these theoretical calculations regarding the interaction of forces and members are derived from the centroid location. So all forces and all members are based around that centroid. The centroid is determined by using a cross-sectional view of a three-dimensional object. So on the left there you see an I-beam. On the right, they're turning it to look at its end, whereas if it was being cut down the middle, and that shape is called the cross-section. So a cross-section of an I-beam looks like the letter I. When we're talking about centroids and symmetrical objects, the centroid is very easy to find. As you can kind of guess, the centroid is, well, the word centroid kind of sounds like center, so the centroid of a symmetrical object and of most objects roughly ends up being near the center of that object. So on this triangle over here, when we look at the triangle and where the line of symmetry is, that would mean that if you drew a line down the middle and folded that shape in half, it would look exactly the same. The same shape would form. So when we look at the triangle, the line of symmetry is right down the middle, and our centroid falls on that line of symmetry from left to right. And then vertically, the centroid is actually about a third of the way up. And we're going to talk about that more when we talk about triangles in a bit. For the square, we have two lines of symmetry because it is a perfectly symmetrical shape. And the centroid is located where the intersection of those lines of symmetry occurs. The same goes for a circle. It is infinitely symmetrical, and the lines of symmetry intersect in the center, and that is where the centroid of that circle is. So if you have any shape that is symmetrical, the lines of symmetry cross at the centroid. So that would be an easy way to find the centroid if you have a symmetrical shape. So when we look at squares or rectangles, our centroid location is located as following. Now, the centroid location has two components. It has both an X and a Y component. So think of it like graphing in math. We're starting from the 0 point, which I always assume to be the bottom left corner of whatever it is I'm working on. And I have an X and a Y location for the centroid. So the bottom left corner of this square is 0, 0. The centroid in the X direction is located at X bar, is what we call that, the X with the line on top of it. And X bar, or the X location of the centroid, is half of its base. So B divided by 2 is the X location. Y bar, the Y location of the centroid, is at H divided by 2. Pretty straightforward. So there is my centroid for my square in this case. It would be the same for a rectangle. It would just be half the base for the x direction, half the height for the y direction. For a right triangle, the centroid is located at a distance of 1/3 of its base and 1/3 of its height. So the x location is 1/3 of the base, and its y location is 1/3 of the height. So base divided by 3, h divided by 3, height divided by 3. The most important thing to remember on this triangle is that the location is always based off of where the right angle is. And the centroid for a triangle only works when you're talking about a right triangle. That is key. You need to remember that when we're doing our calculations. So the right triangle, first off, our triangle has to be a right triangle, and our location of our centroid is always taken from the right angle. So you can't start over here. You have to start from the right angle. So the right angle is your 0, 0 point, and you go from there. X bar is 1/3 your base, Y bar is 1/3 your height. Always from the right angle. There's our centroid. For a circle, it's always right in the middle, so we're not going to talk about that, but we can talk about a half circle. So the centroid of a half circle or a semicircle is located at a distance of 4r divided by 3 pi away from the axis on its line of symmetry. What are we talking about? Okay, so let's talk again about coordinate systems. So if I take the bottom left corner of my semicircle here, this is my 0, 0 point. My x bar, easy. It's just whatever my radius is, because I'm going from here over to the right on this line. So my x bar is the radius of my circle. My y bar is somewhere up in here, and that's where we use this equation. So my y bar is 4r over 3 pi. So if I take that equation, 4r over 3 pi, 4 times my radius of 2 inches, divided by 3 times pi. Make sure when you're entering this in your calculator, I would always recommend using parentheses just to be safe. So put the 4 times 2 in parentheses, divided by 3 times pi in parentheses, and you get roughly 0.8 inches. So again, my x bar, they don't really point this out, but my x bar is just my radius, and my y bar is the equation 4r over 3 pi. And so my centroid ends up in this location right here. Not all of our shapes are simple. Some of them end up being fairly complex. To find the centroid of a complex shape made up of more than one shape, we're going to talk about that in another video to keep things simple. So come back for part 2, and we will talk about the centroid of a more complex shape.